Tie. Get it out. They're not going to see you, all right? You guys are ridiculous. All right. Here we go, guys. So these are your due dates for the unit. All right, make sure you have those. Moving on, get your packet out, the Pogo Worksheet. Okay? We're going to start going through these questions now. Folks, when we do this, this is an introduction. This is not meant for you guys to have to get it all 100% correct. It's to start making the connections, because if you start making those connections on your own, it's going to make things a lot easier later on, or they're going to stick with you longer. If you get them wrong, correct them. All right, that's the idea here within this. So, within this model here, we've got a periodic table with some of the elements, not all of them, and they've got charges. So identify 3 elements that form only one cation. First off, what's a cation? It's a positive ion, guys. So any of them that are positive but only form one cation. What's one that forms one positive charge? Hydrogen. Sodium. Potassium, right? You can list them all, guys. They're all the ones that are right here. They form one cation. And then there's also aluminum. Okay? It's a +3, but it's still only one ion. Right? It only has one charge. All right? Oh, there it is. Oh. No, you see that red blinking dot right there? I am recording. Oh, yeah, so questions you guys ask, they'll be on there too. So just, yeah. Here we go. Next one. Identify 3 elements that form only one anion. One anion, meaning one charge only. What's one of them? Fluorine. Nitrogen. Chlorine. All right, there. Guys, all of these ones over here, they form one anion. All right? And then identify 3 elements that form more than one cation. Iron would be one. Nickel. Copper. Guys, is zinc one that is zinc? Does zinc form one ion? No. It forms one ion, right? Not multiple. Okay? So, when we take a look here, let me go back to the first color. This is one that forms one. This forms one. The reds are the anions, and then we'll do green for the ones that form multiple ions. So right away, guys, we can see that not all elements will form a single charge. Some of them change. Some of them have more than one charge, right? What type of elements, guys, are the ones that pretty much have more than one charge here? They're transition elements, guys. That's what transition means, is to change. So their charges will change based on what they're bonded to. And that's what we're going to kind of look at throughout this entire unit as one of the pieces. So it says, in what region of the periodic table do multiple ions form? Transition elements, okay? The middle. All right, the transition one. So, number 2, consider the ions of potassium and sulfur. Write chemical formulas for all possible ionic compounds involving these ions using the simplest ratio of potassium and sulfur. Keep in mind that some of the charges in an ionic compound must equal 0. What did you guys put for this one? Potassium and sulfur.
K2S.
Why, Briley? Why did you put K2S in there?
Because K has 1 positive and S has 2 negative. So 2 positive plus 2 negative is 0.
Exactly, guys. So that's kind of the idea when we start putting formulas together. Now, if you didn't have that, that's okay. So again, you should be looking through. You should be following along on this worksheet and filling it in as we go along. The last one here says, consider the ions of iron and sulfur. Write chemical formulas for all possible ionic compounds. Keep in mind the charges must equal 0. John? Right? So what did we know? Iron has got 2 charges. Fe2 plus. When we put it with sulfur with the 2 minus, those 2 plus and 2 minus, guys, they will cancel out and be 0. Then when we have Fe3 plus, to get them to cancel out, it takes 2 irons and 3 sulfurs to get a total charge of 0, right? 2 times plus 3 is what? 6. 3 times minus 2 would be? Negative 6, guys. So a plus 6 and a minus 6 will cancel out. Therefore, we'd have that formula. Again, we're going to learn tricks along the way over the next week that's going to help us make this easier. All right, and then we will be able to write formulas like it's no one's business. All right, it's no big deal. Questions on these 3? Moving along. All right, the next model, guys. up there at the right-hand side of your front page. It says circle the symbol for the metal in each of the compounds in Model 2. So for sodium chloride, what's the metal? Na, sodium. All right, Ca, S, silver sulfide, zinc phosphide, aluminum oxide, and then strontium chloride. All right, there we go. It says which element comes first in all of those compounds? The metal, guys. We talked about this in the last unit some. The metal always comes first. All right, it goes back to its electronegativity values. It's got the lower values, so they always come first. In the compound zinc phosphide, what is the charge of the zinc ion? It's a 2+. In the zinc phosphide, what is the charge on the phosphide ion? 3-. Okay. Again, you can go back to Model 1, which was the slide before. If we flip back really quick, we can see, oh, zinc's a +2. So this thing's pretty cool. I've got a laser pointer now. I can kind of point to it. Look at that. +2. Phosphide over here is a 3-. Mine's a little small, so it's a little harder to see, but you have it with yours as well. Okay. Moving along. Number 8. It says the compound carbon dioxide has a name that gives you a hint as to how many oxygen atoms are in the compound. Is there anything in the name zinc phosphide that indicates there are 3 zinc and 2 phosphorus ions in the formula unit? Is there anything that tells you how many you have just by reading the name? No, guys. All right, there's nothing there. So again, these little connections, we're going to see when we start taking our notes in a little bit, all right, how they impact us. All right, number 9, is there any ratio of zinc and phosphorus ions that could exist? For instance, could you have Zn2p or Znp2? Are there any other ratios? No. Why? Okay, what'd you say, Sam? Okay, full octet, that could be part of it. What'd you say again, Briley? There's only one zinc value, right? So yeah, it deals with the octet stuff. Okay, but again, it goes back to those charges. There's only one zinc charge, so it can't be more than 1. Because again, what's the total charge we're trying to get to in a compound? 0. We want to be at 0. So because there's only one zinc charge, therefore there's only going to be one formula. Explain why you don't need to specify the number of ions in the compound when you're naming substances like those in Model 2. What's that? Yeah, they only have one charge, guys. So therefore we don't have to identify how many we have because the one charge kind of dictates how many we have. Only one charge. Model 2 is labeled metals that form one ion. What other metals that also form only one ion could be included in Model 2? Model 1 may help. What are some other ones that could be listed there in that Model 2, guys, with those names? Rubidium's one. I can't write. What else? Rubidium? Metals. Metals. Beryllium. What else for Model 1? Strontium. What else? Barium. What else? What else? Anything? Right, you guys get the idea, right? Any of those other ones from the left-hand side in those first 2 columns, they will be in there. Aluminum will be in there as well, the ones that have one charge. Describe how the names of nonmetal elements in Model 2 are changed when they're in the ion form or anion form. What changes to their names, guys? When you look at that Model 2, that's the second piece. The nonmetals are the second one listed in the name. What changes are made to their names? Ide, guys, that end in ide. That's the change. Ends in IDE. So now we're going to name these compounds right here. Li2O, what's that? Lithium oxide. I'm not going to write them in there. Okay, you guys can write them in there. Go back and watch the video. Lithium oxide is Li2O. MgF2. So I heard magnesium fluoride. I heard magnesium difluoride. Look back at Model 2. Do you see any prefixes in there? In that Model 2? So we won't use the di here, even though there are two. We'll talk about that later on when we get to our notes a little bit more. Okay? Magnesium fluoride. Then Al2S3. Aluminum sulfide. And then K3N. Potassium nitride. Question? All right, provide the chemical formula for each of the following compounds. Barium chloride. What's the charge on barium? It is going to be BaCl2 would be your formula. What's the charge for barium? 2 plus. Chlorine is 1 minus, guys. So you need 2 of the 1 minuses to balance out that 2 plus charge. Magnesium oxide. Tell me the charge on magnesium first. Oxide or oxygen would be 2 minus. So what would be our formula when they balance each other out? MgO. Thank you. Consider the 2 chemical formulas you wrote in question 3. Would the name iron sulfide be sufficient to uniquely identify either of those compounds, guys? So if we wrote the compounds in question 3, iron, salt, and sulfur, what were the 2 formulas that we had? Go back to question 3. We wrote them down already. What were the 2 formulas? FeS or Fe2S. Would just writing iron sulfide be okay to identify them? No. So we need something else. We can see that we need something else, guys, because there's more than one formula with the same 2 elements. So we have to have something else to identify what's going on with our formula. All right, that's what we'll start talking about a little bit later on. All right, so here we go. Now, Model 3, ionic compound names, and this is with metals that form multiple ions. So what other metals that form multiple ions could be included in Model 3? Besides copper 1, copper 2, tin 2, tin 4, lead 2, lead 4, iron 2, iron 3. Any of the ones, guys, in the transition elements that we haven't listed right already. All right, mercury. Mercury what? We had mercury. What were the charges? Or mercury.
Actually, it does say 2 plus, but it says that we have 2 values.
Yeah, because here it is. We both have 2 plus, but the formulas, guys, are different. Hg with 1 Hg is 2 plus, or Hg2, that's actually mercury 1, right? Because we'll talk about that later on in the unit. All right, describe the most obvious difference between the names in Model 3 and those in Model 2, guys. What's the difference between the 2 names, sets of names? Roman numerals. All right, the Roman numerals. Roman numerals. Do the Roman numerals in the names in Model 3 relate to the number of cations or number of anions in the formula unit? What do you think? What do we think? All right. They're actually, guys, they're going to relate to the number of cations. Because what that is, guys, it's telling us the charge of the cation. Okay? It's the charge of the cation. What? Cation? No, cation. Identify the charge on copper cations in copper 1. Copper cations. Oxide and copper 1 oxide and copper 2 oxide respectively. What is the charge on the copper in copper 1 oxide for that cation? It's a +1. And then copper 2 oxide would be +2. Identify the charge on the iron cations here. Iron 2 chloride would be +2. Iron 3 chloride is? Look at that. It's pretty easy, right? What do the Roman numerals, guys, tell us? Their charges. The cation charges. Notice. Hopefully, guys, you can start to see. Every time we have a transition element, we're going to have a Roman numeral. Okay, that's something we will talk about when we get our rules written down in our notes. But they're going to have a Roman numeral every time because they transition. They change their charges based on what they're bonded to. Okay, the last piece here. All right, fill in the table below with what we've learned from Model 3, Fe2O3. You know what? We're going to come back to this actually. Folks, you need to know these 7. Notice, when we look at their formulas, what's unique about their formulas? They're all ions, hence polyatomic ions, so they all have charges. Where's the charge located, though? On the outside of the parentheses. Folks, you will get a list of more than just these 7 common polyatomic ions. These are the 7, though, you have to have memorized for your quiz next Thursday. These are the 7 most common ones we're going to use all throughout the year. The good news is, after this unit, you will have the list of polyatomics in your reference packets that you have on your test. So you will not have to have, but this unit, you've got to memorize them because you can't spend that time just going through and looking them up every single time. We're going to be using them that much. You need to have these common ones memorized. Just like I had you memorize certain elements early on in the year, so you're not looking them up all the time. All right? That's the purpose behind it. CaO2 is an ionic compound or is it a molecule? So first off, let's talk about that, guys, right up here. Ionic compounds, they have ionic bonds and they're called formula units. Actually, let's not do that. Let's highlight. Okay, molecules, as we see, all right, they are covalent bonds. All right, they have what are called molecular formulas. We're going to get into that here within this unit. All right, so going back here to number 1. CaO2, what type of bond is that, guys? What type of compound? What do we have? How do we identify the bond type? Metal and nonmetal. Do we have a metal and nonmetal there? So that would be ionic, guys. This is an ionic compound. The formula for CaO2 is known as a formula unit. All right up here. It says so up at the top. How is it bonded? What type of bonds are there?
Ionic.
They are ionic bonds. Should make sense. An oxygen molecule is what?
A molecule.
Oh, look at that. It's a molecule.
That was a really stupid question. Yeah, I know. I wasn't saying you.
O2 is bonded by what? Now, which one can we eliminate? It's not ionic, so it's either polar, covalent, or nonpolar, but it's the same element, guys, so what would it be?
Nonpolar.
Nonpolar, good. We had our test on that yesterday.
Yeah, where do we get those back?
A chemical formula could be either a molecular formula or a formula unit. Either way, the chemical formula indicates the relative number of each atom in a chemical compound. Parentheses around a polyatomic ion identify it as 1 unit, and any subscripts written next to the parentheses apply to all the atoms inside the parentheses. Circle to fill in the correct answers. Butane, which gives you the formula. What type of compound is that? It's a molecule. Why? Because it is no metal, so it would be what type of bond? Covalent, guys. Molecules are covalent. How many carbon atoms does it have? 4. It's got the subscript 4. How many hydrogen atoms?
10.
Look at that. Super easy. Aluminum oxide is what? It's an ionic compound because it has a metal. Metal and nonmetal. How many aluminum ions does it have?
2.
How many oxygen ions does it have?
3.
Calcium chlorate has how many calcium ions?
1.
This is a tricky one here. What's the subscript, guys, on calcium?
2.
Just calcium.
Oh, but I thought the 2 back there.
Nah, see that 2, this 2 right here, guys, is only for that what's in
That
parentheses.
was a trick question.
Okay? No, that's why we're going over it. There's 1 calcium ion.
Good job, guys.
Now, how many chlorate? Notice it gives you the formula, ClO3 with a minus charge. How many of those do we have? 2, because that's what's inside the parentheses, guys. So we have 2 of those big ions together. Now, when it comes to just the chlorine atoms, how many do you think we have? Oops, I'm sorry, I put that 2 in the wrong spot. There's 2 chlorates. How many chlorine atoms do you think we have?
1.
0.
I hear a lot. Here we go. Let's think about this. I'm going to write this out.
Let's think about it.
I've got ClO3, but I have 2 of those, right? Because it said that in the parentheses on the outside, that's subscript 2. So how many total chlorines do we have? We have 2. All right, we've got 2. Right here, take a look at my laser pointer. There's 1 chlorine here, and there's 1 chlorine there. Therefore, we have 2. How many oxygens do I have now? Yeah, 6. 3 times 2 is 6. All right. You guys try number 4. All right. How many magnesium ions? 3. How many phosphate PO4 ions? 2. How many phosphorus atoms? There's 2 because we're going to distribute this 2 out into each subscript. Okay, so there's 2 phosphorus atoms and how many oxygens? 8. Okay, so yes, this is the first day of this, guys. That's okay. All right, we will get to where we need to be.